Now let's look at some more important constructs. We can't go through all of them, but if we check contracts, we have talked about when, we have talked about pay. We haven't talked about if and let. So let's use an example that has if, and somehow you can't really do anything interesting if there's no money in a contract. So normally contract will always start with a deposit. So we always start with a when, and then at least one party should make a deposit. Let's say we want a contract where one party makes a deposit and then a second party can make a choice and decide who gets the money from the deposit. Let's start with that. We need a case. Let's call that giver again. Okay, these are all things that we have seen already. So we wait for a deposit by party giver until a parameterizable deadline, and the value of the deposit is also parameterizable in ADA for simplicity, and the giver just pays into his own internal account. So afterwards, we want somebody to make a choice. So this is also an action that we have to wait for. So again, we need a when. So let's actually change this and call this deposit deadline. And then here we need a second deadline until when the person making the choice has time to make his choice. So let's call that choice deadline. If no choice is made, we just close the contract. Okay, so now for actions. We have seen deposit. I said that notification is somewhat special and not used often, but choice is important. So let's now see an example of choice. First, choice has a name. Doesn't matter, let's just call it choice, because we will only have one choice here. Choice owner is the party being able to make the choice. So that will be a new one. Let's call that party chooser. Choice bounds. So choices are always numerical. So it's always numbers. But you can specify a bound. So it's always integral numbers. So in this case, if it's 1 and 2, the only two possible choices would be 1 and 2. Last week, we saw an example where the choice was actually a price, these two prices given by the oracle. So there were millions of or even billions of possibilities. So the range was much larger. But actually now the idea is that this chooser can choose between two potential recipients of the money. So let's just leave it at 1 and 2. Okay, and now the continuation. So if this choice has happened, and now we are in a position where we can use the if, because now we want to branch. If choice 1 was made, we want to give the money to one party. If choice 2 was made, we want to give it to another party. So let's put this if in there. Now we need an observation. So a Boolean value that can be true or false. If we look at observations, first of all, we see there are logical connectors. So you can combine two observations with logical and or logical or you can negate. You also have like the atomic observations, true, the observation that's always true, false, the observation that's always false. And then there are interesting ones. So these here are comparisons of two values. So one value is greater or equal than another, or greater, less than or equal. Finally, we can observe whether a choice was made. In this case, we already know that a choice was made. Otherwise, we wouldn't end up in this if contract. So what we need is we want to check whether the choice value equals 1 or 2. So we know it can only be 1 or 2. So the observation we want is we want to check whether it's 1, say. And if it's not, we know it's 2. So this would be value equality. So, and the 1 value will just be the constant 1, let's say this. And here now, Until now, we've only used constant values and this one here, available currency from account. But we see there's some arithmetic possible and something with time, so we can observe the current time, and we can use a name that is used in combination with the let contract that we haven't looked at yet. So in the let contract, you can give a name to a value, and then later you can reference it by this name. Okay, but what we want now is choice. And this is now where this name comes in, because there can be several choices. So we called our choice simply choice, and we know it was made by chooser there. Okay, so what will this do? We know we only get here when this has happened, when the choice has been made, and then this choice value made by role chooser can be 1 or 2 because we set the bounds between 1 and 2. So if it is 1, then whatever we put here will happen, and if it was not 1, then this will happen. In this case, the choice was 2. So in this case, we want to make a payment. So do this. Okay, and the payee is now the one that corresponds to the choice 1. So, and let's pay to his internal account first. Doesn't really matter. So this is now the party that corresponds to choice 1. Let's just call it receiver 1. The amount, well, that's the amount here. That is now in the internal account. The value, we can, for example, use this again, amount. We could also use this available currency again, and it's ADA from the account of, it was the giver, and afterwards we are done. So afterwards we can use a close. Okay, and in the else case, we want to give to somebody else, not receiver 1, but let's call him receiver 2. So let me just copy paste this whole pay block here. And all I need to change is this. We can try it out. Now we see this has already automatically been done, but it's unfortunately the wrong way around. I mean, we first want to make the deposit and later the choice. I mean, we could, of course, now edit that here, but it would be nicer if by default it was already done correctly. And this has to do, if we go back to metadata that I haven't set yet. So let's set some of this metadata now. I think you need to set the metadata for the time parameters for the ordering to work correctly. And actually, you also can change the order of time parameters here in metadata, and that will then later be reflected when you have to enter the parameters in the simulation. So if one comes before the other, then by default, the one will happen 5 minutes before the other, which can of course be changed. But it looks as if they are already in the right order. So let's try this again. Yeah, now it's the right way around. Okay, so now the deposit deadline comes first and then the choice deadline. So let's try it out. We do start simulation. I forgot to set the amount. Let's say, and I probably should set the format for the amount parameter again so that it's nicer and I don't have to enter the 6 zeros. Let's say 100 ADA. Now we can make the deposit. If we don't, then nothing happens. So let's make the deposit. And now participant chooser can make a choice. And we see here we can in principle edit enter other values, but then we get an error. So only 1 and 2 are allowed. So let's first do 1 and make that choice. And the contract ends, and we see here receiver 1. The contract pays 100 ADA from account of receiver 1 to receiver 1 wallet. I could have done that directly. In the pay, instead of using account, I could have directly paid to the wallet. Here now the payment goes to the internal account, and then when the close is hit, it, as I explained before, close always transfers the remaining value in the contract from the internal accounts to the corresponding wallets. So Here the choice 1 was made. The contract then paid 100 ADA from the internal account of giver to the internal account of receiver, and then when the close happened, that ended up in the wallet of receiver. If I go back and make the other choice 2, then we see that instead receiver 2 receives the money. So that seems to work. If we look at the possible contracts, we have talked about when, pay, if, mentioned that a third we won't use. So close we have talked about. So the only remaining one is let. So I want to briefly demonstrate let, even though in this case it's not really useful. So as I briefly explained before, with let you can give a name to a value, and then inside the continuation, the contract that comes after the let, you can refer to this value by that name. So there's this one value here, constant param amount, that we repeat 3 times in this contract. So what we could do is take out this when here, put it inside a let, slot that back into the contract, and now give some name like amount, lowercase, to this value here. And then wherever we use this constant param, we can now instead make use of this use name construct and then refer to it by this name amount lowercase. So I can remove these 2 occurrences here and instead copy, paste that in there, the use name. And the behavior should be exactly the same. Now here in Marlowe, it looks like this. So if we send it to the simulator, set for example 50 ADA this time and start the simulation, let's make a deposit of 50. Let's say we choose 2. And receiver 2 receives the 50 ADA. So now we have seen all the available contracts. We talked about observations, Boolean values that can be true or false. We have seen the actions, deposit and choice, not notification, but as I mentioned, that's quite rare and not very important. Values, and of course we have talked about payee and party and token and also bounce. So now you have seen all the available constructs that you can use to assemble a Marlowe contract. There's one last thing I want to show you here before we go on, namely, if I run the simulation, let's set it to, I don't know, 70 ADA this time. So you notice that now the whole contract here, this whole when, is blue, light blue. So this is the basically remaining part of the contract. So we already did the let, so we are already in a state where this name amount is bound to this value, and now we are here in this when. Now if I make the deposit, we see that the blue area shrinks. So now this is done. This happened, the deposit happened. So now we are in this inner when, where we are waiting for the choice. So if I now make the choice 1, the contract is done and nothing is blue anymore. Same if I made the choice 2. So we always see the remaining part of the contract, and that gets smaller and smaller until the contract is done.